Devices on the internet use internet protocol addresses to communicate with each other and access resources. DNS eliminates the need for humans to memorize numerical IPv4 addresses, including the even longer alphanumeric IPv6 addresses, by mapping domain names into IP addresses. So when you type in www.example.com in your browser, DNS is a system that finds the IP address of the server you're connecting to. DNS operates in a hierarchical structure, starting with the root, symbolized by a single dot. Root servers direct queries to the appropriate top-level domain servers like .com, .org, or country-specific TLDs like .uk. Each TLD then delegates authority to the authoritative name servers responsible for specific domains, such as example.com. These authoritative servers hold the final answer to DNS queries, ensuring that users are directed to the correct IP address. Before we dive into the detailed steps on how DNS works, let's have a look at resolvers and the root server. From RFC 9499, a resolver is a program that extracts information from name servers in response to client requests. Basically, a resolver performs queries for a name, type, and class and receives responses. Root servers are typically the first step in translating domain names into IP addresses. There are 13 logical root name servers. Each logical root server has a single IPv4 and IPv6 address assigned to it. So a common misconception is that we only have 13 root servers. That's not the case. At the time I was recording this video, there were 1,921 root server instances behind each IP address configured via Anycast. If Anycast is configured properly, queries to the root servers get routed to a server that's geographically closest. These root servers are operated by 12 independent organizations. Let's look at a step-by-step walkthrough on how DNS works to resolve a domain name. It all starts when you enter a domain name into your browser. When you hit enter, your browser checks its DNS cache to see if it already knows the IP address. If there is no entry in the cache, the query is sent to the DNS recursive resolver. This resolver may be hosted by your ISP or may be one of the publicly available resolvers. The recursive resolver checks its cache, and if the answer isn't available, queries the root name server, which directs it to the appropriate .com authoritative TLD name server. The TLD name server refers the recursive resolver to the example.com authoritative name server. The recursive resolver then queries the example.com authoritative name server for the A record and receives the IP address as the answer. The DNS resolver caches the result for the duration of the time to live specified on the record and sends this IP address back to your browser, which can then establish a connection to the website server and load the web page. This entire process happens in milliseconds. Finally, let's use the dig command to view all these resolution steps for example.com. The first thing that I'll do is run the dig command without any options and to see the answers that we'll get. So dig example.com. And you can see in the answer section, we get responses, right, for the A record with the IPv4 addresses. So now let's look at the entire process using the +trace option of the dig command. So I'll run the same command, but this time around I'll include the +trace option. And here we can see a lot of things. I'll just scroll to the top. And the first thing that we can see is we've got into the root. We're going to ask the root, how do we get to .com? So the resolver is going to ask the root, how do I get to .com? And then the root server is going to respond with the .com name servers. And in this case, we can see several of them. And the root server that responded, if you checked somewhere down there, is the D root, right? 199.7.91.13. So the D root responded with the .com name server. And the next step is from the .com name servers, we're going to query one of them for example.com, right? How do we get to example.com? When I scroll down, we're going to see the example.com name servers returned, right? So we have two of them. Once we get to that, the next thing is now make a query to these name servers, one of these, for the A record, right? And you can see we made a query and we got the IPv4 addresses for example.com. So we got the answer from a.iana-servers.net. So that's it. That's a walkthrough. You can use this to view the entire process, and at least you'll be able to understand what happens step by step. So the trace option basically just mimics what a DNS resolver does when it looks up a domain. So that's why it's really useful. So that's it. I hope it's been informative. See you in the next one.